Alrighty, I wanted to run through the lesson and the homework for 211. So we, in the previous lesson, have talked about how to graph using x and y intercepts. Basically, what we learned was that for all x-intercepts, y has to be 0, and for all y-intercepts, x has to equal 0. In the warm-up for this section, if you were in class, there was a graph and there were 3 different lines on there. And we looked at all of the y-intercepts and saw that x was always 0, and looked at all of the x-intercepts and saw y was always 0. So what we learned was all you have to do to find your y-intercept is substitute 0 in for x, and to find your x-intercept, you substitute 0 in for y. And the beauty of that is when you look at like this first problem here, when you have 80x plus 40y equals 800, when you substitute 0 in for x, that term with the x, the 80x, goes away because 80 times 0 is 0, and you're left with 40y equals 800. And when you solve for y, you can get your y-intercept. Same thing if you substitute a 0 in for y, then the 40y term goes away, and you end up with 80x equals 800. And when you divide by 80, you end up with x equaling 10. If you look at the graph here, you can see that your y-intercept is 20 and your x-intercept is 10. The start thinking part here was about writing an equation, and we got our equation. They talk about boxes being 80 pounds apiece and drums being 40 pounds apiece, and they're being put in a truck that can hold at most 800 pounds. Now it asks to find out how many drums there would be if there were no boxes, how many boxes there would be if there were no drums, and that's basically finding your x and y intercept. What you can do is just, like I said, substitute in 0 for x to find your y intercept, and substitute 0 in for y to find your x intercept. Then it says create a graph, and you can see the graph there. You can see your x and y intercept. And then the last part says get it into slope intercept form. So these are two different forms. If you look at the equation in step 1 or in question 1, that is in standard form. Standard form is great when you're going over and just graphing using your x and y intercepts, but sometimes that can be problematic, and I'll explain why in a second. And then when you look at number 4, slope-intercept form is great because you can see the slope directly in your equation, and you can see your y-intercept. As you can see, when it is y equals negative 2x plus 20, the 20 is your y-intercept, and if you look on the y-axis, it is at 20, and then it is going down by 2 and over by 1, down by 2, over by 1, and that's called your slope. So once again, if we talk about graphing using x and y intercepts, or looking at that form, and you ask yourself, what are the limitations of this? Number 1, it needs to be in standard form. It doesn't absolutely have to, but if you don't have it in standard form, when you substitute in your 0 for x or your 0 for y, it just makes it a lot harder to solve the equation. The next one, the points between your x-intercept and y-intercept might not be super accurate. If you did not use a ruler, you don't have a nice graph, it's really hard to find those other points in between the x and y-intercept on your line, and making sure that they are accurate. You need to be making sure that you are neat, and then once again, you cannot see your slope or your y-intercept in the equation. Whereas in slope-intercept form, like number 4, the number attached to your x is your slope. When you look at standard form, the number attached to your x is not your slope. Now, going to slope-intercept form is y equals mx plus b, where m is going to be your slope and b is going to be your y-intercept. I know it says plus b, but that could also be minus b. And if you have minus 2 for your b, let's say, that is the same thing as adding negative 2. So your b would be a negative 2. Now, the thing that students usually struggle with most with this is just getting it into slope-intercept form. So what we did was we looked at 5 different equations. They were all in standard form, and we tried to get them into slope-intercept form. We got the y by itself. We then got it in mx plus b form. So you can see the first one, you just subtract x from both sides, you get y equals negative x plus 7. The next one, you subtract 6x from both sides, making sure to put that negative 6x in front of the 10, because we want it in y equals mx plus b form. The next one, not only did you subtract 2x, but then you had to divide by 5, and you end up with negative 2/5 x for your slope and 4 for your y-intercept. The next one, you add 3x to both sides, and no, you cannot do 5 plus 3x equals 8x. They are not like terms. So you get 4y equals 3x plus 5. You divide by 4 on all the parts, and you end up with y equals 3/4 x plus 5/4. Yes, a y-intercept can be a number that is not a pretty whole number. And the last one, when you subtract 9x, you get negative 9x plus 11 on the right, but you got to get rid of that negative, so don't forget to divide everything by -1, which basically switches the signs. We then were looking at graphs and trying to figure out how to write the equation of these lines. The y-intercept is always really easy to see. You just look on your y-axis and see where it goes through. On the first one, it's at -4. On the next one, it's 5. And then we'll talk about number 3 in a second. To find out your slope, you find 2 pretty points. Now, the unfortunate thing with how this scanned in is you cannot see the nice intersections. But basically, where you see my little red dots, those are where the nice intersections were, meaning the crosshairs of the graph go through the point on the line. And what we found on the first one, if you look at your notes, it is going up by 3 and over by 1. And then you're going up by 3 and over by 1 again. So that means the slope is 3 over 1 or just 3. Positive 3 because it's going up from left to right. The next one, when you find your 2 pretty points, I usually try to find the pretty points that are closest to one another. That would be down by 2 and over by 3. So the slope is -2/3. Now number 3 is just a little funky because it is horizontal. And we ask ourselves, what equation would always give us a y value of 3 no matter what x is? And basically it is x is just not part of the equation. The equation is y equals 3. Whenever you have y equals a number, that's just a horizontal line. Whenever you have x equals a number, that is a vertical line, and it's going through the x-axis at that location. This problem right here was mostly just asking about the difference between standard form and slope-intercept form. Number 1 is kind of in slope-intercept form. The only difference is it is b plus mx instead of mx plus b, which is normally what we do. But the beauty of this is that you can see your y-intercept and you can see your slope. Your y-intercept in this case would be the original number of gallons, and the slope would be the gallons draining per hour for the situation. Now the next one, when you have it in standard form, once again, you can make a really quick graph using x and y intercepts. But the problem with this is that you can't see your slope or y-intercept. So when we get into slope-intercept form, you can see your y-intercept and you can see your slope. The last thing we covered in the lesson in class was how to graph. So when you get it into slope-intercept form, you can find out where you're going to start on the y-axis. For example, on number 1, you start at -3, and then you move away from it using your slope. When they have a slope of 2, that is 2 over 1, which means up 2 over 1, up 2 over 1, up 2 over 1. And then you connect your points. The beauty of graphing in this way is that you can follow your points. You're not just doing an x-intercept and a y-intercept and hoping all the other points line up in place using a ruler. You can follow your points, up 2 over 1, up 2 over 1, up 2 over 1. And when we're trying to find an intersection, which we're going to be doing in a few sections, this becomes super handy. The next one, you start at 4, you go down by 3 and over by 5. Notice it is going down from left to right because it has a negative slope. Number 3, could you have graphed using your x and y intercepts? Yeah, but we got it into slope-intercept form, and we found out that it was starting at 5, go down by 4, over by 3, down by 4, over by 3. And then lastly, we talked about if you have y equals -2, that is basically saying it has a 0 slope, meaning it's not going up and not going down, and it is going through a y-intercept of -2. That would be a horizontal line going through the y-axis at 2. Now, when we take a look at the homework here, when they give you an equation like this and it asks what is the y-intercept and the slope, you can't really see it when it's in standard form. So we transformed it into slope-intercept form. And once we had it in slope-intercept form, you could see your slope was -2 over 4, which is the same thing as -1/2. And you could see that the y-intercept was 16 over 4, which is the same thing as 4. Sometimes people just say the y-intercept is 4, but technically you should say 0, 4. The next one says, according to this graph, what should your a and b values be? Now, we know that when you are finding your y-intercept, that is substituting in 0 for x. If we substitute 0 in for x here, the ax term is gone, and then you would have by equals 12. You want to ask yourself, what is the value of b, so that when you solve this, you get that y-intercept of 4, as you can see a y-intercept of 4. So what is the number that you would go over and divide 12 by to get 4? It would be 3. And then the next one is ax, the by would go away because you would substitute 0 in for y to find your x-intercept. And what is the value of a that would make you solve the equation ax equals 12, and you would get a x-intercept of 6, and that would be an a value of 2. That's probably the hardest problem on the homework. The next one says, what is the y-intercept of each of the equations? The first one is easy because it is in slope-intercept form, so it's 0, 2. The next one, you got to get it into slope-intercept form, and when you do, you find out that the y-intercept is 6, so it's 0, 6. And the next one, you had to distribute on the right, and then get that 6 from the left side, get that to the other side. It's not really getting it to the other side, it's eliminating it on the left. And when you do that, you get y equals 6x minus 2. So your y-intercept is negative 2. The next one says Claire knows that Priya has a bunch of nickels and dimes in her pocket. That total is $1.25. Find the possibility for the number of nickels and the number of dimes that could fit in there. Now, my lazy way of doing this is just saying no dimes at all and 25 nickels. You just basically say, how many times does 5 cents go into $1.25? Write an equation that represents this situation. Well, if you're talking in pennies, then it'd be 5n plus 10d equals 125, because you're saying a nickel is 5 pennies, a dime is 10 pennies, and altogether you get 125 pennies. Or if you wanted to do it in dollars, you got to be careful because it's 0.05n plus 0.1d equals 1.25. I'm not a super big fan of decimals, so I probably would do the penny version. But they are equivalent, because if you take the equation on the right and multiply everything by 100, you will end up with the same exact equation. And that is a legal move, multiplying both sides by 100. So the next one, explain what 13,6 means. That means 13 nickels and 6 dimes. Is the point 13,6 a solution to the equation? When you substitute in 13 and 6, you find out you do get $1.25. My only concern about this problem was we're using n's and d's, so it's hard to know, is 13n or 13 supposed to be your d? I just assumed it meant n because that came first in the problem. The next one says Noah has a coin jar, dimes and quarters, total of $5. Which of the following are equations that represent the situation? Once again, if you're talking pennies, D would work. If you're talking dollars, C would work. Parts of dollars equals the $5, or a $5 being 500 pennies. All right, the next ones, we're just making sure you know how to graph. 6a is start at -2, go up 3 over 1, up 3 over 1 because of the slope. The next one, we're trying to graph using slope and y-intercept, not the x and y intercepts. So we get it into slope-intercept form. We find out we start at 3, and then we drop down by 2 and over by 5. And then lastly, y equals 4. That just means a horizontal going through 4. If it was x equals 4, it'd be a vertical line going through 4. Number 7, what are the equations here? You just have to find your slope and your y-intercept. Y-intercept is easy to see. Your slope is how much the rise over run is. So your rise over run for the first one is up 2 over 1, so that is slope of 2, y-intercept of -4. B is going to be down 3 over 4, down 3 over 4, and starts at 5. So it's y equals -3/4 x plus 5. And then lastly, your last problem says, Tamara says that the slope of 2x plus 3y equals 9 is 2 because the slope is the number attached to the x. Is she correct? Explain. She is correct if it was in slope-intercept form, but this is not in slope-intercept form. So the number attached to x is not always the slope unless it is in slope-intercept form. So while slope is the number attached to the x, this only is true for slope-intercept form. All right, thanks for watching.